Good afternoon, everyone. Yaoqi here from Rollup. And for this session, right, I will share with everyone about the economic mechanism for Rollup-as-a-service. Actually, it's a very new topic. I believe a lot of people, we don't probably know what's Rollup-as-a-service. So I will start with sort of why we need a Rollup-as-a-service and what kind of Rollup-as-a-service can provide for us. And after that, we go into the economics step by step. So as we all know, right now, we are sort of in a paradigm shift from this modular design to this, monolithic design to the modular design. Previously, 6 or 7 years ago, we know that for Ethereum and a bunch of these L1s, they're sort of like monolithic chains, basically including execution, settlement, consensus, and also data availability layers together. But right now, as we can see, right, we sort of split this entire test stack into different layers. We can say there's an execution layer as different rollups, and we also have the settlement layer as Ethereum and sort of some other L1s. And meanwhile, since Ethereum is turning into this rollup-centric scaling approach, gradually we can see Ethereum is becoming more and more like a data availability layer. And all the executions will be offloaded to different rollups. And right now we have so much better landscape for all different execution layers. As we can see, right, we have Optimism execution layer, like Optimism, Arbitrum, and the various, the other solutions, probably not just EVM compatible. Meanwhile, we also have different ZK solutions, like ZK Sync, Polygon, ZK EVM, which are EVM compatible, but at the same time, we also have some non-EVM compatible, like Starware. And at the same time, right, apart from the general purpose L2s, we also have different application-specific ones, like what we are building, and also a different research labs building these execution layers for different industries or sectors, like game sector, NFT sector, and the social applications. And since we have so many sort of new execution layers, and for developers, when they want to spin off a different rollup or L2s for the applications to cater for millions of users, right? Sometimes they are quite confused, like which L2 or which test stack we should choose. And we can see a lot of SDKs, but how to incorporate or integrate these SDKs into our existing test stack, and how to deliver these L2s and attach to different L1s. It's sort of a little bit headache for the developers. And that's why we need these Rollup-as-a-service providers and these kind of companies and projects. For Rollup-as-a-service, right, we make you can treat it a little bit like software as a service. For these companies, we incorporate all these SDKs and also different test stacks into these kind of solutions. So in that case, for developers, if they want to launch rollups or L2s for Ethereum, you can just leverage some dashboard or existing tools and quickly spin off these L2s and posting data or deploying bridges on Ethereum. And as you can see, right, even for RaaS, or Rollup-as-a-service providers, right now we also have a quite extensive landscape of all the different solutions. We have SDKs, we have different sequencers, site provisioning, and at the same time we're also providing these different no-code deployment. As I mentioned, right, so right now we are already at the stage that compared to 6 or 7 years ago, we have to build from source code or using some SDKs. But right now, we have a bunch of these dashboard platforms. So you can just choose the parameters you want. For example, define the names for your rollup. And then within a few minutes, you can launch a rollup or L2 for you. So, and then, as we can see, right, there are a bunch of benefits we can achieve via Rollup-as-a-service, especially from different Rollup service providers. So one that is really flexible. and low cost and fast deployment. As I mentioned, right now for most of the RaaS providers, basically we can quickly spin off the rollup depending on your requirement within a few minutes. Beyond that, as I mentioned, right, for a lot of these developers from Web 2 industry or gaming sectors probably don't understand like how to really launch a blockchain, and at most they know how to develop in Solidity. So in that case, they need this kind of no-code framework. That's something we are providing, and also a different Rollup-as-a-service providers providing. So as we can see, right, this becoming a trend that for a lot of developers, you can just call the API or their dashboard, quickly spin off the L2. You don't need to worry about like sort of read the source code or like debug these SDKs. Right now, it's really like AWS in crypto industry. You just quickly spin off these rollups and L2s for your applications. In that case, right, how we really monetize these kind of solutions or services. As I just mentioned, right, we need this kind of rollup-as-service to quickly spin off the rollups and for our applications. But how, like these providers like us or the other companies make money? So one straightforward idea a lot of us may think about is why not directly apply this SaaS model into it? For example, when developers spin off the rollup, right, let's charge some fees directly, either similar to GitHub, right, GitHub or AWS. For GitHub, it's sort of like subscription model, right, it's per seat. If you have more developers for your organization, we charge higher fees for this deployment. But at the same time, you know, we all know that, right? For rollup, typically it lasts for a long time, and we can charge fees either month by month or like sort of like year by year. So in that case, it's quite similar to the existing SaaS model. You can connect to the Stripe and some other payment services and just charge user fees as a normal software. And in this model, right, the good thing now is quite straightforward. We have a lot of mature solutions for this SaaS model. Regarding payment side, right, we have Stripe and a lot of different payment systems, even crypto payment system from Coinbase and some other providers. And in that case, you just need to input your credit card, and sometimes you can pay in crypto. And based on that, as I just mentioned, right, they're also tiered pricing. Probably you can have a starter tier, developer tier, and a corporate tier. For different tiers, like we can provide different services. Starter tier, we can provide some, like sort of you can only have one seat in your organization. At the same time, you can only launch one rollup at the same time. But for developer tier or corporate tier, you can provide much better like services. Like you can launch 5 rollups at the same time, or corporate tier, it depends on your demands, right? We can launch as many as you want. Meanwhile, there are also hybrid pricing, and for a lot of projects, right? At the beginning, we can charge no fees, like apply this freemium way. Like probably for the first one or few months, it's free for you if you really like to use it, and later on we can extend sort of the subscription by charging some fees. And beyond that, we can also provide credits and to attract the users or developers, and later on we can charge based on the usage. Apparently we can see that if we directly apply the SaaS model, it's quite straightforward, right? But you know, right, we are in crypto, and rollup is quite a new area like we enter into. So there are some complexity if we want to apply this SaaS model. So let's look at like what are the steps and what's the cost and what's the revenue we can have from this SaaS model or from the rollup space. And then we will see like how much like sort of revenue we can get from it. So this is a quite straightforward rollup workflow overview, right? We have sequencers, basically collect transactions and aggregate transactions from different users. And after that, typical sequencer or executor execute the transactions and compose blocks. And basically later, regularly, there will be either sequencer or submit the data to the L1. And typically, there are also fraud proof or validity proof on the L1. If there's something wrong happening around the L2, we have different ways on the L1 where the smart contract to verify these proofs and to challenge these sequencers. This is a typical way, right? But typically, how we charge fees from the users for these L2 systems. As we are using like probably Optimizium, Arbitrum, or zk-Sync, Polygon, zk-EVM, right? We all know that when we pay fees, it varies a lot depending on the time we send the transaction. So why the fees is not constant? Because it's not just like sort of the gas fee on the L2. It also includes some of the fees we need to pay for the data when the sequencer posts the data on the L1. So more specifically, as you can see, right, L2 fees typically means the like normal gas fee, right? Like what we can see from the recent launch Linear, the gas price probably just 8 GV. Since it can handle a lot of transactions, typically the gas price is quite constant. But at the same time, it will frequently like post the data to the L1. Then like during this period of time, right? It really depends on how many transactions for this period of time. If we have a lot of transactions, right, we can sort of like average this cost for every user. But if we only have very few transactions, like 10 transactions, then everyone need to cover higher fees for the data posted to the L1. So that's why, as we can see, right, the fees we pay to the L2 is not constant, even the gas price is the same. So then, as we can see, right, so there are a lot of places for user to pay the fees to the L2, but at the same time, L2 actually is making money. This is a chart from Optimizium and also Arbitrum to record their revenue and also the cost. The cost is mainly about the post the data to the L1. For most of the L2s, we sort of like charge extra fees. We overestimate the fees and charge the user because we may concern that if we don't charge enough fees, later there's a sort of gas war or gas surge on the L1. We don't have enough gas to pay the data we post on the L1 like Ethereum. So that's why if you look at the data, right, for Optimizium, Arbitrum, actually for the past few months, they already made a few $1 million. Basically, the fees they collected from the users and then deducted by the sort of fees they pay to Ethereum for storing the data. And then let's look at some like sort of like some formula or some these kind of like results we composed from the discussion just now, right? So typically, we charge the user fees based on the L1 data publication and also the L2 operator fees plus L2 congestion fees. Assume there's so many transactions, like every second we need to process 1,000 of transactions. And then the operator cost is quite straightforward, right? The running the machine, like for example, machine from AWS, Google Cloud, or bare metal machine, plus the L1 data publication cost. And at the same time, right, operator also has the revenue. Here, I count the user fees plus the MEV. MEV is another topic, probably like once we have time, we can discuss more about it. And then the profit is basically the revenue minus the cost and basically, as you can see, right, it's just like aggregation of the user's transactions and minus the L2 operation fees. More specifically, right, if we consider the normal general purpose rollup as one case, right, then as a RaaS provider, if we provide the similar services to run a general purpose L2, then the cost and also the revenue and profits we get should be quite similar. So that's the case, as you can see, right? We have different like sort of roles consisting of fees and the costs. And in the end, for the operator, is basically we can collect the fees from the users and also some service costs. service costs from the customers, for example, game company or NFT companies, and then just manage this cost and also basically the data we need to post on the L1. But there's another case, since it's for general purpose L2, right? But for a lot of the L2s or applications spin off the rollup, they are quite application specific. A lot of customers talk to us like big Web2 game studios. What they want zero fees, zero gas fees. They want to provide the user seamless experience, just like the Web2 gaming. So in that case, right, we probably cannot charge the fees from the users. At the same time, there's no such like MEV fees because they want first come, first serve. So in the end, right, for a normal RaaS provider, for some application-specific use cases like games, NFTs, and probably social applications, the overall profit will be much lower than providing a general purpose rollup L2. And as I just mentioned, right, beyond the transaction fees we can collect from the users, we also charge extra service fees. As I mentioned at the beginning, right, we can apply this SaaS model on this Rollup-as-a-service. So what kind of the SaaS model we can have, like this is subscription-based, or we can also charge commissions from the NFT sale or some tokens. That's quite unique in rollup space or in crypto space compared to the traditional SaaS. And beyond that, the other ways are quite standard, right? Either it's flight pricing or sometimes usage-based, like pay-as-you-go, similar to AWS, or it's per user pricing, GitHub-like. Like for each organization, more members, and we charge you more. And then in the end, right, so based on the formula, as I mentioned atop, right, so it's still like we can charge some user fees if a general purpose L2. If it's application specific and it doesn't charge any gas, so that part is zero. And the service fees we always charge unless we have some free credits for the customers. And beyond that, there are always the cost running L2 operators. Like for optimistic rollup, mainly like we need to spin off like machines on cloud or bare metal places. But at the same time, right, we also need to post the data on the L1. So that's L1 data publication cost, the D, the initial D. But for this part, right, we can also save some money by playing some like sort of mechanism here. Like for example, right now there are a bunch of DA solutions, right, like EigenD and Celestia. Or we can even compose a DA committee and to store the data, like this starware they call Validium. So in that case, like we try to increase the profits, try to increase the revenue by U and S, but at the same time we try to reduce the O and the D. That's sort of the way, like if we really want to apply this SaaS model into this RaaS space, that's sort of the formula we get. And of course, right, I just want to share a little bit more about that sort of the cost based on our experience. So for the RaaS cost, as I just mentioned, right, the major cost is really about the operation for the L2 operators and typical we call sequencer verifiers. And meanwhile, there are also the DA cost. And a lot of people ask us, right, so right now we already have the OP stack, ZK stack, and various execution layers. So what's your opinion on the cost on this? So based on a lot of like investigation and also comparison across different solutions, typically if we are applying this optimistic rollup approach, right, the cost is much lower because we don't need to run a super expensive, like for example, $500,000 machines to do the ZK proof. That's a part we can save a lot of money. But of course, there are also trade-offs. Sometimes we need to experience the long challenge period. But overall, as we can see, right, optimistic rollup in general, the cost is relatively low. But ZK part, like we need to cover mostly on the prover cost. That's the major cost. For optimistic rollup, basically we just need to consider more about like where we put the data. Like for example, it's on Ethereum or sometimes on the other DA layers. The status quo for the RaaS, right, as I just showed you. So basically, we have these different pricing plans, like flight pricing, tiered pricing, and also different models. But it typically highly associated with our use cases, like NFT mint, gaming, and sometimes it's sort of like we make it free credits for a lot of partners. And for the past few months and 2 years, right, either us and also some of our projects, we did a lot of these applications via the RaaS, like empty campaign. We also support a bunch of these football matches, these NFT ticketing. And meanwhile, a lot of game plays like Dark Forest. So these are the real-world use cases, and for most of them, right, it's quite straightforward, just like typical SaaS payment model. And a very interesting one, like you can just scan the barcode. This is something we did recently. We provide the service, and basically everyone can play it. It's fully on-chain. Every transaction, every move is a transaction on-chain. But at the same time, we make it really latency-less. So basically, you cannot experience any latency for this one. So these are the use cases, like sort of we try to apply this SaaS model. Of course, like today, I also want to show something quite different for the traditional SaaS model, right? That's a way like we try to decentralize the entire RaaS sort of landscape and try to make it as decentralized as possible. So that's how we have this beacon layer, or we call this enshrined it layer for rollups. You can treat it as like orchestration layer. And when user want to spin off a rollup, they directly talk to the beacon layer and send requests, and beacon layer will assign dedicated like sort of operators for these clients, and they will spin off for these applications. The cool thing that, as you can see, right, the first version we provide is really a RaaS dashboard. Basically, you can spin off via the very centralized way. But later on, we have this beacon layer. We make everything decentralized. So people, like all the audience here, we can join as a solo staker or solo sequencers into a network. And later on, once we get some like sort of demands and requests, so the protocol can quickly spin off like the validators from you and to serve these applications. And as I just showed you, right, compared to different RaaS or SaaS model, now it's quite decentralized protocol. You send a request, and this beacon layer will assign some of the community nodes and to serve these users. And meanwhile, it also provides like decentralized sequencing, decentralized verification. And meanwhile, as we all know, right, if we rely on the security on the L1, there's a validity proof and also fraud proof. Sometimes it takes a little bit of time, right? But with this decentralized beacon layer, we can quickly do the verification, and then you can have this harder than soft finality. Beyond that, compared to the traditional RaaS SaaS model, right? Now, since we have the decentralized protocol and everyone can join as a node, and then you can provide the service for different applications as the rollup nodes, right? And then there's a bunch of ways we can make it right, like a normal and a very decent economic flywheel for this decentralized protocol. Because as the Ethereum community, right, we always prefer decentralization compared to centralized service. So that's why we really make this brave move to really decentralize this RaaS platform into this decentralized protocol. And then at the same time, right, we are still having a lot of open problems. For example, it's no longer SaaS, right? Then for decentralized protocol, how we get enough nodes and to serve different applications, and meanwhile, how we capture the MEV and during all the different applications across the different nodes. And beyond that, some application want some customization, right? Since it's quite decentralized, how we make the customization possible? And like Justin just mentioned, right? Right now we have some risk-taking services. How we apply the risk-taking service into this decentralized RaaS model so we can really enjoy the benefits from ethers. So that's all the open questions, and we hope we can, together with all the audience and the Ethereum community, we can explore all the different new ways to really decentralize the RaaS landscape and meanwhile to capture more values for Ethereum. Thank you.